All right, good morning, students. Today we're going to be doing geometry, section 1.3. Here goes my stellar spelling. Good thing I'm teaching math and not spelling. All right, geometry, section 1.3. Inverse of a function, and we're going to explore how are a function and its inverse related. So the first thing we're going to talk about is just plain inverse. What does inverse mean? Well, inverse is just opposite. Inverse is just the opposite. There's plenty of opposites in the world. There's the inverse of addition is subtraction. Inverse of multiplication is division. Inverse of up is down. Inverse of black is white. Plenty of examples of inverse or opposites. Now, how does that refer to in a point? Let's say I have point A, and that's 2, 5. Let's say that's my point. What is the inverse of that? The inverse is 5, 2. So what's the relationship there? What's the relationship? Well, all it is I swapped the x and y. So I changed the x and y. So the y became the x value. The x became the y value. That's the inverse. It's that easy. Let's say I have point G is -1, 3. The inverse is often written as -1. So the inverse of G would be what? Well, it'd be 3, -1. I don't change positives and negatives. I don't do anything. The only thing I do is I change the x becomes the y. I'm sorry, the y becomes the x, and the x becomes the y. That's all the inverse is doing. Y becomes x, x becomes y. So let's look on page 12. You see you have this function here. 0, -2, 0.5, -0.75, 1.5, 1.5, 1.75. So you have this function here. Now if we were to write the inverse of this, if we're going to write the inverse of this, we would simply turn this x into the y. So we would get the x becomes the y becomes the x. So we just write these reverse. X becomes y becomes x. X becomes y becomes x. X becomes y becomes x, and so on and so forth. So if you have a table of a function, it's pretty straightforward to write the inverse of that function, just by writing the x's as the y's and the y's as the x's. Okay. If we were to go to page 13, let's go ahead and do that. Let's do that. So we want to write the inverse of this function. So if we're going to write the inverse of this function, my x becomes my y value, and y becomes my x value. X becomes the y value, y becomes the x. X becomes the y value, y becomes the x. X is the y value, y is x. Right, this is 3, 4, now I have 4, 3. This is 4, 5, now I have 5, 4. 5, 6, 6, 5, 6, 7, 7, 6, 7, 8, 8, 7. My x became y and my y became x. Now, let's see how a function and its inverse are related. Let's see how they're related. So I'm going to go ahead and draw my x, my y, somewhere in the middle. Okay. So what I'm going to do is I'm going to do my original function in lead, and I'll do my inverse in blue, and we'll see the relation. So 0, 1, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5. All right, so we see a pattern here. And I can go on, but I'm out of space, plus we know the pattern. So there's my function. Now let's look at my inverse function. I have 1, 0. I have 2, 1. I have 3, 2. I have 1, 2, 3, 4, 3, 5, 4. Okay. And there is my inverse function. I'm going to say this is not the best one to show this example, but our inverse function is a reflection across y equals x. Oops, I should put it like this. Y equals x. It's a reflection across y equals x. So y equals x would be 1, 1, 2, 2, 3, 3, 4, 4, negative 1, negative 1, negative 2, negative 2. So I have this y equals x, and if I were to fold this piece of paper, if I were to fold this right over my y equals x, or my red line, I would see that they line up exactly on top of each other. Exactly on top of each other. So your y equals, your inverse function is a reflection across your y equals x. Now I'm going to show you a couple more examples, because this one with the slope of 1 over 1, they're going to be parallel. But most of their inverse functions are not going to be parallel. Okay? So let's go on. Alright, the inverse function. For your vocabulary, inverse function is reflection across line y equals x. Okay, I'm going to pause this video, and I'm actually going to give you another better example. Okay, we're back, and I've decided what we'll do is we will just start in on your homework, and I will show you another inverse function relationship. So let's look right here. Let's go to number 1 on page 15. So we have, oh, here's number 1, I'm sorry. Number 2 you can do. I'll do number 1. So here we have our function. We have 1, negative 1. We have 2, 5, 4, negative 2, 6, 8, 8, 9. So what I'm going to do is I'm actually going to put a chart for number 1 so that we can see its relationship to y equals x. Alright, so I have 1, 1. So my inverse function is going to be negative 1, 1. Actually, you know what? Let's just go ahead and let's plot our function first. Let's plot our function first, and then we could plot our inverse. So I'll do my function in red. 1, negative 1, 1, negative 1. 2, 5, 1, 2, 1, 2, 3, 4, 5. We have 4, negative 2, 1, 2, 3, 4. Oops, 4, negative 2. and then 6, 8. 1, 2, 3, 4, 5, 6, and then 8. Be all the way up here, and then 8, 9 is going to be off. But we're going to see how this is reflected across your y equals x. So our inverse is 5, 2. Our inverse is negative 2, 4. Our inverse is 8, 6. And our inverse is 9, 8. So that's what it's asking, is finding the inverse right there. Now, what actually happens is each one of these is going to be reflected. This is going to be hard to draw. So, let's reflect these. So I have negative 1, 1. So if you see, if we folded this over, this would be a reflection across this y equals x line. 5, 2. 1, 2, 3, 4, 5. 1, 2. So do you see how these are reflected across this axis? And then negative 2. 1, 2, 3, 4. So this one and this one are reflected across, and then we would have these would also be reflected. So there you go. There's your inverse function, or inverse relation. That's your inverse relation. So go ahead and do your inverse relation for this one. This one is the same thing. You're just going to have input and output. So we're going to have 6, 1. Then we're going to have 3, 4. Then we're going to have 0, 4. We're going to have negative 1, 8. We're going to have 13, 17. So you see, if I had written these out individually, I would have had 1, 6, 4, 3, 4, 0, 8, negative 1, 17, 13. So that's how I got my 3, 4, and 0, 4, because the 3 and the 4 and the 0 and the 4. So make sure when you have two things coming out, even though it's not a function, there's a relation, and we want to do the inverse relation. Okay? Now, this isn't the inverse. So let's see why they have these. Give me a second. Okay, I'm sorry. Not exactly sure why they have these, but I think I might understand. So when the output is 3, so what that means is we're not plugging 3 in for x, we're plugging 3 in for the output. So you're going to go ahead and plug in 3 for the output. I'll do number 5, you do 4 and 6. So if I plug in 3 for the output, I get 3 equals 3x minus 2. And so I have to solve this to find my input. So I'm going to solve it just like I would in the other equation. I'm going to add 2 to both sides because I'm trying to isolate the x. So I have 5 equals 3x. Now I have to, this step, I have to divide by 3 in order to get the x by itself, to get the x independent. So I have 5/3 equals x. So that's my input if my output is 3. So go ahead and solve 4 and 6. Alright. Now, I'm going to show you one more technique for solving these. Okay? So, one, you could make a chart. You could make a table. make a table. So I have my x and my y, and graph the function and its inverse. So we're going to graph both of them. So I'm going to do my first one. So I'm going to do my first one in black because this is my function, 4x. So let's say I have 0, I get 0. 1, I get 4. 2, I get 8. I'm going to do a negative 1, and I get negative 4. So here's my function. Let's graph this. So I have 0, 0, 1, 1, 2, 3, 4. 2, 8 is off the charts, so I'm going to go negative 1, negative 1, 2, 3, 4. So there's this line. Okay, that's my function. Now my inverse function is going to be, 0, 0, 4, 1, 8, 2, negative 4, negative 1. I simply flip these, right? It's just my y's become my x's. My x's become my y's. So 0, 0, 1, 2, 3, 4, 1. 2, 8 is too far. I'm sorry. Yeah, 4, 1. 8, 2 is too far. Negative 4, negative 1. Negative 1. 2, 3, 4, 1. So there is my inverse function. Now I told you I was going to show you how it relates to y equals x because it's a reflection across y equals x. Well, negative 1, negative 1, negative 2, 1, 1, 2, 2, 3, 3. So here I have this line, y equals x. Now, I'm hoping you can see, if I were to fold this line across, if I were to fold it across there, these would be a direct reflection. If I folded it across this line, this would line up on, this would end up on here, and this would end up on here, or this on here. So that's its relation. These are opposite. These are reflected across y equals x. Okay? So that's one way you could do it, is by doing the table. Now, another way you could do it is simply by changing your x and your y. So let me show you what I mean. Here, this function is y equals negative 3x plus 2. There's our function, right? Now, if I want to do the inverse, all I have to do is change my x and my y. So I have my inverse is x equals negative 3y plus 2. All I did is I switched my x's and my y's. Now I need to solve for y because I need this to be written like a linear equation. So I would subtract 2. So I get x minus 2 equals negative 3y. Divide by negative 3. So I get, don't forget this is a 1x, so this is 1/3 x, right? So these cancel out, so I'm left with y equals, and then I have negative 1/3 x plus 2/3. So I just found my inverse function by switching my x's and my y's. And now we're supposed to graph them, so let's graph them. So for this one, oh, I'm supposed to do those in pencil. So for my original function, I have a slope of negative 3 over 1 and a y-intercept of 2. Slope of negative 3 over 1, the y-intercept of 2. Let's see if I can do this. Oops. Not quite centered, but you know what they say. So 2, and the slope of negative 3 over 1. So negative 3, 1, 2, 3, positive 1. 1, 2, 3, positive 1. Oops, again, this is supposed to be in pencil so we can see the difference. Negative 3 over 1. So there's that one. Now I have this one where my slope equals negative 1 over 3, and my y-intercept is 2/3. So 2/3 is right about here, and negative 1 over 3. Negative 1, I can't get the rest of it. So there's my line. Let's compare it. So these are reflections across this. This one is reflected over here. This one reflected over here. So the reflections across the y equals x. Okay. Hopefully that made sense. Let's do one more. We'll see how it goes. So this one I'm going to do the same thing. I'm going to switch my x and my y's. So I'm going to say x equals 1/2 y plus 2. Subtract 2. X minus 2 equals 1/2 y. And then to get rid of a half, I have to multiply this by 2. So I multiply this whole thing by 2. So those cancel out, and I get y equals 2x minus 4. Y equals 2x minus 4. So let's graph both of these. So for this one, I have a slope of 1/2, y-intercept of 2. Y-intercept of 2, a slope of 1/2. 1, 1, 2. 1, 1, 2. One, 1, 2. And for my inverse, I have a slope of 2 over 1, and a y-intercept of negative 4. 1, 2, 1, 1, 2, 1, 1, 2, 1. And now to see its relation to y equals x, you can see this is reflected to here, this is reflected to here. So there you go. Alright, your homework is to complete numbers 1 through 12 on page 16. If you have any questions, please ask. Alright, have a wonderful time. Give me a call or an email if you have any questions.